number 6, where we'll talk about sulfur dioxide measurement and management. Let me go ahead and launch our first poll today, just checking in with how you're currently checking your sulfur dioxide. So are you checking, how often are you checking sulfur dioxide in your winery? And which detection methods are you using? And if you use multiple methods, just choose the one that you use the most often. And how confident are you in the results that you receive from that method? And I would say on question number 1, if you're somebody who checks at a different frequency, then there's like an option for, if you're an other, just maybe put in the chat box what your other is. So while you guys are voting on that, I'll just say that, you know, it happened, the first experiment we'll talk about today came about because pretty much every year I get at least 1 or 2 or 3 phone calls or emails looking at was somebody asking me what's the best detection method for sulfur dioxide. And it makes sense. The sulfur dioxide, probably after Brix and maybe pH, is the thing that we test the most often in the winery, rather than sending it off to somebody else. And we make a lot of decisions based on that number that we get from sulfur dioxide testing. We have to decide if we're going to do an addition or not, and how much we're going to add. It also makes sense because there's a lot of different methodologies, right? So some of you may be using the Ripper method. Some of you may be using something that relies on the same underlying chemistry as the Ripper, but has sort of dealt with some of the problems with the Ripper, like the Hanna titrator or the Vinmetrica. Vinmetrica sort of helps to deal with the endpoint detection, which is a little bit tough when you're using the Ripper on red wines. And the Hanna titrator also uses a different methodology for endpoint detection, but also sort of gives you an automated titration, so you have a little bit less sort of user error in that sort of titration piece. Kind of the gold standard, if there is one, would be aeration oxidation. This is the one in the literature that seems to be most often used in small to medium-sized wineries, that has probably a little bit lower error rate than the Ripper does, and it's still relatively inexpensive to get set up. But there certainly are other methodologies as well. If you have a spec, there are Megazyme or Unitech kits available to look at sulfur. The problem with all of these is that they all require acid to be added to the wine before you measure the sulfur dioxide. And the problem with adding acid to red wine before measuring sulfur dioxide is that acid causes some of the sulfur dioxide that's bound to anthocyanins to be unbound. And therefore you count those as free sulfur, when in reality in your wine, they're bound sulfur. So there's sort of that known problem with all of these methodologies. So there's a new one kind of that's a little bit there in the literature, looking at the headspace gas detection. Unfortunately, this isn't really one that's ready for prime time and regular production use quite yet. So when we get back to that question, which is the best method for determining free sulfur, the answer is always, it depends. And it depends on a lot of things in terms of what the situation is at your winery. So obviously we are all concerned with accuracy. We want our number to be as close to the actual number as possible. But we're also concerned with precision. We want to make sure that when we do the test, we get a similar number every time, and we don't have to run, 5 or 7 different runs in order to kind of figure out what the average is in order to get to be accurate. Startup costs are important. How much does the equipment cost? But also per test cost is important. If you're running a lot of sulfurs in your winery, then if it's $1 per test, that cost can add up over time. And then lastly, it really does matter how approachable the test is, that ease of use. First, the first aspect of that is how much do you actually have to train to become proficient at the test? And then secondly, how much time and effort does it take for every test that you have to run? Most of you all are wearing multiple hats in your winery, so having that ease of use is pretty important. So let's go ahead and look at what our answers were here. So it looks like when we look at how often you guys are running sulfurs, you're looking somewhere between the majority well, close to the majority are every 2 months. We have some folks, about 25%, looking at every month. And then a couple of other folks doing it less frequently than that. So again, the answer, what's the best test, might be very different for folks that are doing that at different frequency. Looks like aeration oxidation is about a little bit more than 50%. And I would say every time we ask this question, aeration oxidation is usually about 50% or a little bit more. About 16% using the sort of the manual ripper, 21% on the Hannah titrator, and then a couple of folks using the service lab, and no one is using their spec for this. And we'll delve into that in another experiment, but that's an interesting result to me. And then when we look at confidence, I think that I'm glad to see that most people feel fairly confident or very confident in the sulfur dioxide testing that you're doing. I think some of the information that we'll see in our results today will help us to see a little bit more what the span of possibility is and the numbers that we could come up with when we're running these tests in the lab. So like I said, I get this question, which is the best method for SO2 every year. This year, that question came from whoops, I went the wrong way. Let's see. That question came from Phil from Whitehall. And Phil was in the enviable position that he had come into a winery that had a well-equipped lab and had choices of which SO2 method to use. So he did a lot of homework on his own before he came to me. And he had also sort of come across that information on the headspace gas detection method. So Phil and I started talking about SO2 efficacy, how well the tests work. And we looked into the literature together, and there are some papers that look at the error rates of these tests and the precision rates of the test, but most of those are done in situations of research laboratories or people that are spending most of their time testing sulfur dioxide. So we thought that this might be a really good opportunity to say, how do those numbers relate to the small to medium-sized winery that's running, let's say, between 5 and 30 SO2 tests per month, not 5 to 30 SO2 tests per day, because we would expect to have our precision rate be a little bit different that way. So we realized as we started to put together this experiment that just one experimenter probably wasn't going to tell the whole story. So Phil went ahead and recruited 2 friends, and that's when AJ and Rachel came onto the project. And we convinced them all to do a fairly rigorous amount of testing. So let me tell you what they did, and then we'll see what the results look like with that. So we decided to use aeration oxidation as sort of our baseline for a couple of reasons. As you just saw in your own numbers, aeration oxidation is probably the most prevalent test that's used in the small to medium-sized winery. It's also thought to be pretty accurate, so it's a good one to kind of compare against. And the other thing, the startup cost for it is fairly small. So if anybody decided to do AO, it's not a huge investment to get that set up. And most importantly, each of our 3 experimenters had access to an aeration oxidation rig. So before we started, we did want to make sure we were all we were all working off the same protocol. So we did get together. AJ has a nice big lab so that we could get together and keep our social distance with our masks on and go over that protocol together. So we had a written protocol that came from a couple of different sources. We went through the instructions together and clarified some of those and changed some of the language to make sure that things were in a good order, to be good directions. And then we edited those and sent everybody back home so they had a good, clear protocol to work from. We did go over the techniques and the measuring devices that were necessary in order to do that protocol well. And we also talked about reagent standardization. So we went through those together to make sure that when we were doing aeration oxidation, that we had a good protocol to follow and we were following all the calibration steps and that sort of thing. So these folks went back to their own labs, and we started phase 1 of our testing. So the phase 1, we just were looking at aeration oxidation to start, just to get that baseline number. So each of our experimenters, we sent them 2 wines in the same little shipping boxes that we send you guys your wines for tastings. So they were in those little round bottom flasks. We filled all of the wines from box wine standard on the same time, or the same day at the same time in the same way. So hopefully they should all be undergoing the same conditions. For each of the 2 wines, there were 5 replicates. So they got 5 bottles of white, 5 bottles of red for each of our 3 experimenters. And we felt like that would give us an opportunity to look at at how repeatable the measurements were, meaning within the lab, if AJ runs the same thing 5 times, how likely is she to get the same answer? But also how reproducible that is at different labs. And so if AJ convinces a friend to start using aeration oxidation, how transferable is that repeatability to another laboratory? So both of those are measures of precision. It's a little bit hard to do measures of accuracy with sulfur dioxide. So when we look at accuracy for other things, we have very static reference standards that we can use to compare back to. So when you do an enzymatic on malic acid, you use a standard and the malic acid hasn't changed since last time. Unfortunately, with free sulfur, that's not the case. Free sulfur dioxide in any wine or any liquid matrix is going to interact with whatever is in that matrix, including oxygen that might come in over time. So there's not really a good way to do a standard for sulfur dioxide. I looked through all of the different studies that people had used, and they used one of 2 methods. One was looking at sort of comparison to a large mean. So if you take everybody's data, come up with the mean, then you can say how close was everybody else to the mean. That works when you have like 100 different labs. With 3 different labs, that doesn't work so well. The other thing, though, that you can do is you can send it to a trusted service lab under the same conditions and at least have a number that way. So that's what we did. We filled the bottle for ETS at the same time. We shipped it to ETS, and everyone read their wines within a couple of days of each other. So after phase 1, we took a little bit of a break, and then we came back for phase 2. In phase 2, we did pretty much the same setup there, but instead of just doing aeration oxidation, everybody did that amount of wine for aeration oxidation, and then the same thing for the Hannah titrator. So in the end, they did 5 white wines with AO and 5 white samples with AO and 5 white samples with the Hannah titrator, 5 red for each one. The reason we chose the Hannah titrator really was, I think you saw in your statistics there, it does seem to be one that a lot of people are using. There tends to be some controversy whether people love it or hate it. And it was one, again, that all of our experimenters had access to and were considering using as part of their methodology. So it seemed like the next one to look at. So before we jump into results, I do want to tell you just a little bit about how aeration oxidation is working. So we're going to do a quick 101 here. There is a full protocol for this in the report that I put into the chat box. So if you want to know all the nitty gritty on the appendix on that report tells you all of them. But aeration oxidation is really built on the chemical understanding that when you take sulfur dioxide in wine and you acidulate the wine, the sulfur dioxide moves to the molecular form. And we know that when we think about thinking through like the antimicrobial efficacy of our SO2. Well, aeration oxidation takes advantage of that and basically has you put your wine together in a very acidic environment in the round bottom flask that you see sort of at the bottom of this rig. Once you put that together, basically the free sulfur almost all goes to that molecular form. And the reason we want it in the molecular form is that when you add air to that aspiration tube, it basically blows air in and the molecular sulfur volatilizes. So molecular sulfur is volatile, and once you start to bubble it, it goes from the liquid phase into the gas phase. Because you're applying positive pressure of the air there, the volatilized SO2 and then sort of moves through that tubing up into the chamber at the top where there's hydrogen peroxide in this sort of trap. So as it moves up there, it bubbles into that pear-shaped flask on the top. And when it does that, it interacts with hydrogen peroxide. Hydrogen peroxide lends hydrogen ions, which interact with your SO2 to form sulfuric acid. So all that means you've volatilized the SO2. Any of the SO2 then has traveled up into that little trap and become acid. So the amount of acid that you have in that trap is directly proportional to the amount of SO2 that you started with in your wine. So now all you have to do is figure out how much acid you have in that flask. And that's where you can detach that flask and go over to a burette that has a basic solution in it. The base is going to counteract the acid. And the way that we know that we've gotten that to happen, you'll notice we have our hydrogen peroxide in our flask there, but there's also an indicator solution. So when the indicator, when that solution is basic, it's green. And when it's acidic, it's like a magenta color. So when you start, it's green. Once you bubble your SO2 in there, it turns magenta. Then you unhook it from there, you bring it over to your burette, and you drip NaOH in there until it turns color again. And that tells you that the base, all of the base, has neutralized all of the acid. Because you're in a burette, you can measure how much NaOH it takes to do that. And then there's a calculation to say, well, if I use this much NaOH, I must have had this much hydrogen sulfide, or this much sulfuric acid, which means I must have had this much SO2 to begin with. So all of that to say, it's a pretty it's a pretty transparent type of reaction. You kind of, when something goes wrong, it's pretty, the troubleshooting is not so difficult because there's only so many moving parts. So just to give you a picture of what that looks like, again, I remember you start with a green solution in your flask. You titrate until you get to this, and it becomes magenta when it gets acid in it, and then you titrate back to a green solution. So to give you a mental picture of that, I'll show you a quick little video of that titration. Basically, this is what it looks like when you first take it off of the clamp. There's a little bit of NaOH that's gone in there, and then you can see that it changes color. So it's a pretty clear color change when you get there. So that is what's happening with our aeration oxidation. So again, in this case, we had two wines. We had a white wine, which we used Franzia Refreshing White, and we used Franzia Merlot as our red wine. And honestly, this is just what was on the grocery store shelf when I went to pick it up before I dropped it off for Jolie to fill the bottles. So there was nothing special about these wines. Okay, so let's look at what the results look like then. So round one, remember, aeration oxidation only, 3 different experimenters. And I've chosen to show these as box and whisker plots because they're able to show us the full range of the data as well as the mean, and then the probability that we'd get something within a certain space. So when you look at the box and whisker plot, the little line in the middle of the box, that's the mean. So if you take all of them and do an average, that's where that little line comes out. The ends of each of the whiskers, those are the total span of the data. So if you're only taking one SO2 measurement, you could get anything within that range. And then the box itself shows you what's going to happen 50% of the time. So it's the first quartile to the third quartile, but basically it's just showing you 50% of the time your answer will be within this box. So what we can see here, oh, I'm sorry, and then the ETS, the red line will always give you whatever the ETS number was. In this case, we also sent these at the same time to another lab to do general chemistry, so I've given you those numbers as well. So what we can see here, I think, first of all, our averages are actually not that far off from the ETS number. So if you look at where that mean line is, the mean for all of them was somewhere around 17.5. So 17.5 versus 20, that's a pretty acceptable difference, and most of us would be fine with that. And that was true for our red and for our white. But we can see a big difference here in the precision between our different experimenters. So experimenter number 1 is somebody who does aeration oxidation all the time and has been doing it for a number of years. And you can see that experimenter number 1 has a high level of precision in doing this test and getting the same answer or close to the same answer all the time, or close to all the time. Whereas experimenter 3 was brand new to this. This was really, experimenter 3 learned this technique when we did our training at Hark. And so this really shows that when you first start a technique, sometimes it takes a little bit of time in order to kind of become precise in the measurement. Now, if we look at the overall average, experimenter 3 is actually just as, if not more accurate in terms of getting close to the ETS number than our other experimenters. But if you take any one of those data points alone, there's a relative span there. So it's a good thing to realize if you're introducing a new technique, sometimes you need to do replicates until you get within a range that you're comfortable saying, hey, I could make a decision based on that. Okay, so that was round 1, aeration oxidation only. Round 2, we looked at aeration oxidation versus the Hanna titrator. So, so the first time, again, with the white wine, we see basically the same kind of trend that we just looked at. In this case, our averages are all a little bit lower. Oh, I'm sorry, that happened before. Our averages are still a little bit lower than our ETS number. But I think the other thing to realize is that experience story is also told with the Hanna titrator, but sort of on the flip side. So in this case, experimenter number 3, though they were new to aeration oxidation, experimenter number 3 uses the Hanna titrator frequently. And you can see that, the experimenter number 3 is very precise with regard to the results from the Hanna titrator. Whereas experimenter number 1 almost never uses the Hanna titrator. And we can see that experimenter number 1 got a really, really wide range. Now, I don't want to leave experimenter number 2 out of the whole conversation. Experimenter number 2 was sort of the middle child, right? So kind of in between, had some experience with both, but doesn't use either one of them on a really frequent basis at this point. So, so that's what happened with round 2, so the second time around, but with the white wine. So let's go ahead and see what happened with the red wine, because I think it really tells the story for us. So look at what happened with our red wine. We can see that the role, I think, of experience here. We see that our precision gets much better for all of our experimenters. Experimenter number 1, 2, and 3 had high levels of precision with both AO and the Hanna titrator. So having basically done a number of replicates within a week of these particular tests, basically the dexterity of that is getting a lot closer. We do, however, have a problem with accuracy at this point, right? So if we consider that our ETS number is a standard for us, and we can debate how standardized we can get with an SO2 number, we can notice that pretty much all of our averages are below what ETS is returning to us. So another thing, when you're sort of testing proficiency in your own lab, you want to look at that number of for repeatability, but you also want to say, is there any systemic error? Is there anything that's causing an error that's always going the same way? Then there might be something in my protocol or in my apparatus that I need to look at that might cause that to happen. So again, if we think about what that might be for our aeration oxidation rig, if we think about aeration oxidation, let's see, there we go. There's a couple of things, because we know what's happening here, there's a couple of things that we can think of if our number is too low. The first thing would be maybe our flow rate is low. So there's a particular flow rate that's recommended for that bubbler. Usually it's between 1 and 1.5 milliliters per minute. And that was actually based off of a paper that was written in like the 1980s. I have it in here. Let's see, in 1970s, late 1970s, that basically looked at, if your flow rate is low, it doesn't matter how long you run that test, you're always going to come back with a lower number. If your flow rate is high, you can run that. Basically, the idea is to max out all of it. So basically, you just max it out sooner if your flow rate is high. But if it's low, you might be getting that chronically low number. Another thing with AO to look at if your number is low is just to make sure all your tubes are sealed. So there's a lot of little places that things can loosen up. And if they loosen up, you lose SO2 as you bubble that air through. So keeping that in mind. And then the other thing is your NaOH concentration. So when you're doing that titration, you're determining how much sulfur you have by how much NaOH you use. And if your concentration's too high, you'll use less NaOH, and therefore it'll seem like you have less SO2. Now we standardized all of ours. So I think in our case, it's most likely to be the flow rate. You can get a flow rate detector, which I did not have until about 2 weeks ago. I ordered it like 3.5 months ago. And so before we do the next phase of testing, I'll bring that around and test the flow rates of the different rigs that we're using here. And then the same thing, if the flow rate's too high, if your value is too high, you can go back and sort of troubleshoot what types of systemic errors might lead to something being too high in this particular case. Okay, so with that though, we also wanted to talk about the ease of use. Remember, that was an important thing when we're thinking about evaluating our technique. So let me stop sharing my screen if I can get it to stop sharing. It doesn't want to stop sharing. I'm going to go ahead and bring our experimenters in and have them start talking, and I'll try to stop sharing my screen as that happens. There we go. There we go. So if Rachel, I know you had to, Rachel, I think had to switch to the car. So if Rachel, if you are here, if you're in a place, okay. So Rachel, why don't you, we'd really love to know kind of, are there elements of doing this test that's not shown by the numbers? So when we look at sort of the ease of use, that ease of use question, what was your experience in terms of the ease of use of these different tests? And what would you tell your your fellow winemakers here in terms of advice about using these two different techniques in terms of accuracy and precision?
Yes, so AO was completely new to me. I am experimenter number 3, so I got a lot more comfortable with it over the course of this experiment. It's And I think it's nice that there aren't any like electronic components to have to troubleshoot with it. But realistically, in the course of a day, it was a challenge for me to be able to focus on it. I think the first round that we did was like the week before we bottled. And so there were like deliveries coming in and out. And like, there were times when the timer didn't get turned off in time. And we weren't able to measure it right away. And so that was a little bit of a challenge. And then also some other troubleshooting I found was that just because I wasn't completely set up for it yet, not knowing really how to do it, I was mixing up some of the pipettes at the beginning from the hydrogen peroxide and the acid solution. And so that was throwing my numbers way off. So once I realized that and just kind of made sure I was dedicating a pipette to each, my precision went way up.
Now you have the Hannah titrator like totally dialed in. So do you have any advice for people on how to use the Hannah titrator? Because not everyone has it that dialed in.
Results are not that accurate though.
Well, I mean, but that might be about the device, right?
Yeah, I think we could not get the probe to calibrate the last round. So I think maybe that's why the results are off. And I'm not really sure why it wasn't calibrating. Or maybe it's just at the end of its life cycle, but we've only had it for less than a year. So I don't know. But yeah, I mean, same thing with the Hannah is just making sure that everything is rinsed in between uses and there's no cross contamination. And then when you first start, there's a little bit that's like wasted out of the tip before it starts titrating. So you have to make sure that that is going into like a waste container and not into the solution or the sample.
Okay. Thank you. So just to clarify one thing that Rachel was saying, so the AO, basically you set it up and then you set a timer and you let it bubble for 15 minutes. And then you stop the timer at the 15 minutes and do the titration. So it's passive time, like you can walk away and do something else, but you do have to come back and stop the timer and do the titration. So time-wise, it's a little harder to fit into the day. So,
and 15 minutes is like just long enough that you think you can get something done, but then you start walking away and can't actually get anything done. So it's kind of a hard interval.
Okay. So AJ, how about you? You might be like the flip side story here. So tell us about your experience doing these two different tests.
Well, I mean, I've been doing AO for a long time now, since I started way back when I was at NAPS. And so I have no problem with AO. I've been using it consistently on a monthly basis. I check our SO2s here usually monthly. It depends. And it depends on how many wines we have and what I'm doing. So I can run anywhere from 24 to 30 SO2s in a month down to 5. Right now I just have 1 that I'm doing monthly until harvest. And so I'm really familiar with it. And of course I used to do it daily when I was at Chaps. So for me, that 15-minute interval, I think it was my prior experience when we were having to do things, at a larger winery, that 15-minute interval, I can go in and I can get stuff done and it's not a problem. I've got the timer on my watch and I'm a little obsessive compulsive about certain things. So I think it's a little bit easier. And then also it's just ease of use. I had used the Hannah titrator at another winery and I'd used it for Hark initially when we were borrowing space out of 53rd. I used a Hannah titrator until we could get the lab here. So I had about a year of using Hannah and I had very similar results then. two separate titrators. I had the one that I purchased for Hark and then the one at the other winery. And it was always just kind of, the numbers were always kind of random for me. I did this time around have to get a new probe for my titrator because I'd put it away since 2019, May of 2019. And I needed a new probe and some of the new solutions. And so even with the calibration standards and the new solutions, especially on those whites, so I was experimenter number one, everything was all over the place. With the reds, it seemed to dial in a little bit more, but I was doing the exact same SOP for it. So I don't know if it's my equipment, maybe the titrator just needed to rev its little self back up after having been put, in a closet for a year and a half, or if there was something else in there. So
I do feel like there's a lot of like little tubes in there. And so there may be some, there may be the opportunity that something gets stuck or you have an air bubble or that sort of thing. And it might be that once you use it for multiple uses, then it kind of, it essentially gets warmed up, but you kind of clear those tubes, anything else. So,
yeah.
All right. So Phil,
Phil came over.
Oh, go ahead. Yeah.
Oh, Phil had come over, was it like a week or two before, Phil, where we were playing with our probes and trying to figure stuff out?
Yeah, that sounds about right. Trying to get them up and running and matching.
Yeah. Calibrate everything together.
Yeah. So Phil, you were experimenter number 2. You were the one who brought the question initially, and this was part of a decision process for you. So what do you think, having done this, what was your experience with each one of those? And what are you going to do when it's time to run the next SO2 at Whitehall?
Yeah, boy, that's a great question. Honestly, I think pros and cons to both are probably the most important thing when choosing which method to use. If I have a lot of tasks that I need to get done for that day, I would naturally revert to wanting to use the handed titrator, simply because you can knock out, in our case, five iterations in the course of what it took to run 2 AOs. So if you have a lot of wines plus a lot of tasks to complete for that day, I think that played into, those are some of those kind of those soft dynamics, if you will, that inform our accuracy. If we run them in the beginning, if you're a morning person running AO in the morning when you're maybe most alert, you might get better results than you would at the end of the day when your attention span starts dwindling. So all those little variables, I think, play into it. The other thing that I reflected a lot on was the input variables that come along with AO. I actually reached out when we had to order a bottle of a couple of the reagents. I think one of them was actually the phosphoric acid, and I had ordered it from a regional supplier and sent them an email asking how long had the bottles been on their shelf for. And so that there's another control element there that from a supply perspective, you can control what you have when it comes into your possession, but you don't know what's happened to those materials prior to you purchasing them. So that was something that kind of sat with me. And I think really, like a case in point, the hydrogen peroxide, I had run AO a few times late or kind of about this time last year with a bottle of hydrogen peroxide that was in the cupboard, and lo and behold, no results were coming back with no color change. Well, hydrogen peroxide, of course, has a shelf life, especially if you maintain that 0.3% concentration. So all those little things kind of come into play. And for me, having said all that, frankly, I kind of lean towards the Hannah titrator when appropriately calibrated, with those little asterisks after me saying those, when appropriately calibrated with fresh solutions, and all those things that come along with it. So I think that's kind of where I leaned. I think having both in your lab is important. My last point is simply because that way you can check across 2 different modalities to see if your results kind of are on par.
Well, thank you to all 3 of you for doing this. We just a couple of points that have come up. So Melanie did ask, does it matter what color it is when you get to the green? And it definitely does. So if you actually look at the report at the very in the appendix, I actually put some pictures in there that were supplied by AJ and Phil. There's a very distinct, like you want to be right at the color change, but not too far. So if you get it to the olive green, it's good. If you're to the bright green, you've gone one drop too far. But there's some pictures in that protocol.
So I think I had a hard time when I was first trying to set up my AO of like starting at the right green.
Oh, so
which is why I wondered if I don't start at quite the right green, is it okay if I titrate back to not quite the right green or no?
So if you so you want to start like when you first set that thing up at the top, you want it to be green. If it's not green, you didn't necessarily do anything wrong. Your water might just not be quite basic enough, and you add like one drop. Usually, if you're not more than a drop off of that, it should be fine. You're well within kind of a reasonable parameter there. So that's a good question. And then one other point, and then we do want to make sure we get time for Kirsty. I'll say a quick thing. AJ, I saw you put your hand up there, so I'll give you a second. Go ahead and say what you need to say.
I just find that I don't get, of course, I'm shade differentiation colorblind. So it's a tricky question for me, but I just find that it just automatically goes from that gray green to bright green. I don't get like a darker, at least I don't think I'm getting a darker green in there. It looks bright to me.
Well, I think,
and
I think that might depend sometimes on how much indicator solution you have in there, but really you want that one drop past the gray. You just wanted, you don't want to go 2 drops past the gray. You want to go 1 drop past the gray. So, and one other thing with reference to shelf life, the most important thing with regard to shelf life is your NaOH solution, which is known to actually lose efficacy over time. Your hydrogen peroxide solution. You do want to start with a concentrated solution and dilute that and not keep the diluted solution more than a day because it does lose efficacy. The acid itself has a much longer shelf life, but those are known. They may be in the protocol I sent you, and if they're not, they'll be in a newsletter that I send out in the next couple of months. There are some guidelines for that we can follow. So thank you guys so much for doing this. We will have more time for questions, maybe if you guys want to stick around toward the end, but we want to make sure to get to the second experiment that we have to look at today. So the second thing that we're looking at today, we just talked about measuring SO2, but we also have lots of practical questions about how to basically manage the SO2 in the winery as we're going along. Even if you have a great measurement number, you still have to decide what to do about that. And Kirsty has basically been on a quest. I don't know. she's done 3 years of experiments around a sort of given theme. So I'm going to go ahead and we'll have another poll here if I can figure out how to do it. Sorry, here we go. Okay, so and basically her experiments have to do with how much SO2 you're adding at that moment when fermentation is finished. So in red wines, when malolactic is finished, and white wines, either when alcoholic fermentation is finished or when malolactic is finished, depending on what you're doing with those wines. So that first add that you add, how much are you adding? That sounds like a tongue twister, but while you guys work on that, I will go ahead and give us our next set of slides. Okay, there we go. Okay, so just to give a little bit of background on this, and then we'll look at the poll results. So Kirsty basically started looking at this question in 2018. And the question started out as, is it better to have this smaller addition early on and then kind of top it off to your target? Or is it better to do one big add and then kind of let it drift down to a bottling target later on? So in year 1, she basically had 3 kind of comparisons along the way. She had one set of barrels where one of the barrels got 30 parts of an addition and one got 75 parts. Those were neutral barrels. She had another set of barrels with the same addition rates that were new barrels. And then she had a third set of barrels, also neutral barrels, but there she waited, I think it was 19 days that year. after the completion of malolactic. And just to clarify why she's doing that weighting, the primary binder of SO2 when you do that first addition is acetaldehyde. And if you wait a little bit of time after malolactic is done, when those bacteria are done eating their malic acid and they're done eating the citric acid, they will start to consume acetaldehyde. So if you give them time to consume that acetaldehyde, you might get a little more bang for your buck in that initial addition. So when she did that in that first year, let's see if I can, there we go. If we look at what happened at the end of that 2018 edition, what she found was that the barrels that got that bigger dose were closer to her 0.5 molecular target throughout aging than the barrels that got the lower additions, but neither one of them spent most of the time at 0.5. So even with a 70-part initial add, by sort of a couple of months later, they were below that 0.5, and she had to do additional adds there. The ones that got that higher initial add did have lower accumulation of volatile acidity because they were closer, well, presumably because they were closer to the 0.5. The new barrels had lower free sulfur, probably because the barrel itself was binding up some sulfur dioxide. So if you're one of these people that has maybe a 10-barrel lot, and 3 of them are new barrels, it might be useful to measure the new barrel SO2s separate from the neutral barrel SO2s, at least until you get them evened out. And in that case, we did see increases in volatile acidity and microbial counts in those newer barrels versus the neutral barrels. And the other thing was that delaying that SO2 addition indeed did give Kirsty more bang for her buck in terms of the addition. So when she added 70 parts to the neutral barrels on a delayed schedule, she had more free sulfur than if she added it right away. And when we did these in sensory, the wines were significantly different, but the descriptors didn't really tell us very much. So we weren't entirely sure what was significantly different about them. So in 2019, basically the question was, well, if 70 parts or 75 parts is good, but it doesn't get us there, how big do we have to go in order to be really above our 0.5 molecular most of the time? So Kirsty decided that she was going to do this again, but this time add 75 parts versus 100 parts. All of these were delayed because it seemed to work last year. So she decided to adopt that as part of her strategy for SO2 management. So all of these went in 2 weeks after, or all the SO2 adds went in 2 weeks after malolactic was finished. And again, in this case, she had 3 sets of barrels. The barrels themselves were pretty much the same. We just wanted to have replicates in that case. So what she found this time around is that 100-part add did allow the wines to do most of their aging above 0.5 molecular. And by the time we had measured how much SO2 they had in April, which is when we did our analysis for them, they had drifted down to being about between 27 and 31 parts. So if you're kind of worried, if I add 100 parts, am I going to be bottling at 50 parts? That didn't seem to be the case for Kirsty here. VA accumulation was low overall in all of the wines, so we didn't get any indication there if we had better or worse VA management with regard to those additions. We had a little bit of shift in anthocyanins, but the color itself was the same. But in this case, I think that the sensory data told us the biggest part of the story here. When we did sensory, these wines were significantly different in the triangle test. But more importantly, I think when we look at the descriptive scores, for aromatic intensity, fruit intensity, and overall wine quality, they were all significantly or nearly significantly higher for the wines that had 100-part add. And the thought process there was that, aging at or above that molecular target was doing a better job of preserving the aromas and the fruit that was present in that wine, not letting it get either microbial spoilage or oxidation along the way. So, so Kirsty, you have done 2 great years of experiments on this. What did you want to look at this year?
Well, I feel like I've got the red wines dialed in at this point. I kind of know my strategy, but I wanted to see how it would work in white wines. So that's why I chose white wines this year.
Okay, great. So this year's experiment's basically the same setup, but we did this in whites versus reds. And again, white wines, you might have slightly different consideration, right? So we're worried about microbial spoilage in our reds and want to hit that molecular target. With whites, it's usually a little easier to hit that target because the pHs tend to be a little bit lower. We don't have tannins to help with oxidation. So we might worry about oxidation a little bit more in our white wines. But we also have a little bit more delicate sensory. So having more sulfite around might have more of a sensory impact as well. Okay, so let's go ahead and look at what you guys are doing first, and then we will jump into our experimental results here. So for the most people people tend to be adding between 41 and 60 parts to their reds and about the same to the white. So it doesn't, that distribution looks like people are doing about the same for one versus the other. So we'll see in this case if we get the same results for one versus the other. So let me go ahead and tell you the things that you have in your flights. I'm going to tell you the key for both of those flights so that you know what you have in front of you as we go through a brief look at the chemistry and get to our sensory. So flight number 1 was looking at the set of barrels that came from the Seaview Vineyard. And I'm going to have to move this because I can't see it. I'll go ahead and read this off in case you're like on a tiny screen. If you're in group 1, wine 684 and 722 both had a 75 part add. If you're in, and wine 203 had the 100 part add. If you're in group 2, wine 315 had the 75 part add. Wines 555 and 151 had the 100 part add. If you're in group 3, wines 322 and 553 had the 75 part add, and wine 836 had the 100 part add. If you're in group 4, wine 870 had a 75 part add, and wine 184 and 678 had the 100 part add. So that's what's going on in that set. So maybe you can arrange your bottles, but we'll go ahead and look at the second one also, so that we can look at them side by side as we look at the chemistry. The second flight came from the Blenheim Vineyard. Still, both of these are Chardonnay. If you are in group 1, wine 798 had a 75 part add. Wine 631 and 473 had the 100 part add. If you're in group 2, wines 233 and 663 had 75 parts, and wine 858 had 100 parts. If you're in group 3, wine 754 had 75 parts. Wines 730 and 999 had 100 parts. And if you're in group 4, wine 862 and 704 had 75 parts, and wine 667 had 100 parts. Whew, that was a lot of numbers. All right. So so when we look at these wines themselves, the chemistry was not uncommon for Chardonnays that came in this year. I'm really just showing you this to show you that the fermentation kinetics were steady and not wonky in any way in any of these barrels. If we did see any sort of sluggish fermentation, we might think that the fermentation itself was giving us acetaldehyde and causing more binding. That wasn't the case in this case. So we kind of feel like we've got good comparisons in both barrels happening here. The general wine chemistry, again, was very much the same between all of them. We expect it to be. The one thing I wanted to point out here was the volatile acidity. We had very low volatile acidity overall, and there was not much volatile acidity accumulation in either one. So in this case, you don't need that big add in order to avoid volatile acidity. That's all that's meant to show us. But the more important question for us is really what's happening with the sulfur dioxide. So when Kirsty took the SO2 numbers in January, on the Seaview Vineyard, both of the barrels were above the 0.5 threshold, so they did not get an addition. And then when she took them again in April, we can see that both of them clearly had decreased in SO2. We expect that. Her goal here was a 0.5 molecular. So we can see that our, number-wise, number-wise, both of them were above 0.5. I don't know why it's graphing out to slightly below, but it was above, and so it didn't get an addition. After aging, of course, the one that had the higher add still had higher SO2 and was above that antimicrobial number. The one that did not have the SO2 add did not make that number. Now, there's two lines here for a particular reason. The first time we ran this SO2 for the lower dose, it came out as 0. And when we looked at that, it could legit be 0, or it could be something went strange in the test. I will say that this also went to a service lab that came back with 0. But Kirsty reran the test, and it came back at 14. So that just sort of shows us what we were just talking about in the last experiment, is that sometimes you get somewhat of an aberrant number. If you're doing regular testing, or if you know what you expect in terms of that depletion, it's helpful to know that, to say, maybe I need to rerun that and see what that number looks like. When we look at this though, generally for antioxidant protection, we think of about 20 parts per million as being the baseline for antioxidant production in white wines. And at the pH that this wine is, antioxidant protection would be just above 0.3 molecular. So in this case, that wine had drifted below what we would even think of as antioxidant protection over time. So what you guys are tasting today is this unadulterated, what it looks like here at these SO2 numbers. Since there hadn't been an addition, we wanted you to taste what it tasted like just out of the barrel. We'll look at it when we look at the Blenheim Vineyard. Right in January, when the Blenheim Vineyard, first of all, it had a higher pH, so the sulfur level that was needed to get to 0.5 molecular was higher in this case. Kirsty needed a 38 part free sulfur in order to get to 0.5 molecular here. And in January, neither one of them was at that level. So Kirsty went ahead and did a 30 part addition to the lower one and a 10 part addition to the higher one in order to get those SO2s up. This is as a bar graph instead of a line graph because it's not continuous because we did that addition. When she went back and looked in April, the lower one still was not at that antimicrobial target, even though it had received its 30 part addition. Whereas the higher dose one was past that antimicrobial target. Now, the reality is we also wanted you to see kind of apples to apples in terms of free sulfur. So Kirsty went ahead and did an addition to this one so that you could taste wines that were at the same sulfur level on this one. So the first one had sort of the same management, the second one had the same sulfur. So that was a slight difference in what we're comparing in those two different plates. And then the last thing that we'll look at with regard to numbers was the microbial numbers. So again, we're thinking about SO2 in terms of antioxidant protection, but also antimicrobial protection. Now, a thing to say about microbial numbers, if you have like really big amounts, like 10 to the 6 cells of microbes, like doubling that might not be that big of a deal, but an order of magnitude difference is a big deal. When you have smaller numbers, doubles or triples, it gives us more of an indication. In this case, we had notable numbers in 2 different microbes. So when we look at the number of acetic acid bacterial cells in suspension in that barrel, so these were not stirred throughout aging and we didn't stir them before we took the sample. So this was just what's floating around in the wine. We can see that the wine that received the 100 part addition had 10 times less acetic acid bacteria than the one that got the 75 part addition. And that happened in one of them was 10 times different. One of them was slightly less than that, but still notably different in terms of its order of magnitude. So when you look at the scale on the graph here, that's a logarithmic scale. So it's 10 times from one node to the next. We also did see a decrease in the Brettanomyces population. In this case, it was cut in half. Brettanomyces, this is a pretty low population to begin with. We don't think about that so much with our white wines, but it was something to look at to say that we did have more efficacy against our microbes in this case. Okay, so that's what's happening with, let's see if I can do this in there. Okay, so that's what's happening there. But the most important thing, of course, is how these taste, right? We're concerned about the chemistry, but in this case, we're also concerned on the effect of what that sulfur addition might be doing. So let me go ahead and launch our next poll to see if you were able to tell the difference. So we're curious to see, were you able to tell the difference between the wines? And then based on sort of that chemistry and the sensory that you just did, if it was up to you, would you add 75 parts or would you add more? Or I'm sorry, would you add that 100 parts? Okay, so with that, let's go to you, Kirsty, and have you tell us a little bit, what was your impression of these wines as you were tasting through blind? You and I have tasted these a bunch of times not blind. So what was it like for you to taste them blind? What did you find?
Really difficult. When I've tasted these wines with you, there's a very apparent difference and we are able to talk and have intelligent conversations. Today, I got both of these sets completely wrong. I did not get, so I don't know if it's an off day, but I didn't get either set right, which is really kind of frustrating. So I am really curious to see if everybody else, or if anybody else was able to tell a difference. Now going back to them, knowing that which ones they are, of course, it's really obvious to me. Give it, especially in the first set, the Seaview set. The Seaview is in 2018 barrels. The Blenheim is in 2011 barrels, if that helps you guys or hurts you guys at all. But I'd really love to hear what you guys think, or maybe I don't know if the poll results are coming back in.
Yeah, we've got we only have about half of the people have voted so far. So we'll give it just a couple more minutes to see the results of those coming through. But Mark had a question that came in, so we can talk about that first. So any consideration given to more periodic dose of SO2 to maintain the levels versus several months later? So yeah, that difference for you between, letting that sit for a while or doing that monthly kind of thing. What's that consideration for you?
The consideration for me is if I have to do it monthly, I will likely forget, or it will not happen monthly. In doing the experiments in 2018 and 2019, when I was working with red wines, and I told Joy, oh yeah, I'll measure them every month, no problem. When I actually looked at how often I did it, it was not even close to every month. So I was using that as the consideration as well. I would prefer not to have to futz with them lots of different times. I would prefer to have one edition, top every 2 to 3 weeks, and not really worry as much about SO2. So that for me, in the workflow that I am able to do and other tasks that I have, I would prefer one larger edition and then hopefully maintain an SO2 of, decent molecular value so that I don't have to think about it for a while.
I think also, just to add on to that too, when you were doing those in 2018, I think the amount that you needed to add to catch up, it takes longer to catch up. And so even when you were doing them more often and kind of doing a little add, we found that you basically never caught up until I think March. And so, there's that idea of at least starting big enough that you could catch up, or maybe that second ad needs to be bigger. Maybe that's another thing to think about, and just realizing, on average about, half of the SO2 that you're going to add is going to bind to something, depending on where you are in the life of the wine. So that's, I think, another thing we saw in those data, that, if you are going to do that sort of topping it up version, you have to go a little bit bigger on that top up than you would. You can't just add the difference. You have to add like twice the difference in order to try to get there at that stage of things. So.
And that's also really confusing, because that changes from wine to wine based on what's happening in the wine. So it's hard to know exactly how much to add to make sure you are hitting that target.
Yeah, exactly. Okay, so let's go ahead and look at our poll results, and then we can continue our discussion. So it looks like it's about 50-50 on for both of the wines in terms of whether people were able to tell the difference or not. So I'll have to run it's right about the 50% split that, like, you have to run the statistics to know if that's statistically different or not, because there's a 3-part choice and we're giving 2 anyway. So I'll have to run the stats on that, but it's not overwhelmingly different, right? It doesn't seem like this is, oh yeah, I could definitely tell there was a lot of sulfur in there. And then in terms of sort of what people would choose to do, seems like that's pretty 50-50 as well. And that might just be dependent on what the differences are in people's perspective on that. So Sharon is sharing that she detected the difference in both of the flights, but she preferred the 75 parts in the first flight and the 100 parts in the second flight. Sharon, are you at a place where you can unmute yourself and tell us why you preferred what you preferred about the first one and what you preferred about the second one?
Yeah, I got sort of off aromas and flavors in the whichever one I didn't prefer, but it kind of crossed. They were sort of, I was getting things that were harsh. And from the first flight, I got a very petrol-y type thing from the 100 parts per million, where I was getting nice lemon curd and lime zest from the 75 parts. In the second flight, I was getting like almost a hairspray type aroma from the 75 parts, but I got beautiful honeydew and melon from the 100 parts. So I don't know why they were crossed, but I was getting something very harsh from one set.
Okay.
Just not the same set.
Well, so it wasn't consistent either way.
Right.
Okay.
Yeah.
Other folks, we had kind of an even split between 75 and 100 in terms of ads. So so anybody else, was there something that you noticed that really made you want to go to 100 parts, or made you really want to go to 75 parts?
Don't be shy. We're all friends.
Joy, this is Phil. I was gonna give a pause real quick. Honestly, for me, the 836, the one that I believe had the 100 part per million for flight 3, round 1, I believe. I don't have the stats
So
in front of me
so
again.
that had 100 parts.
So for me, immediately, it was very, very different than the other two. And I initially wrote down kind of Parmesan cheese, that butyric acid. But honestly, I don't know if that's common to sulfur dosages, but knowing that sulfur kind of creates that kind of burnt match in overages, it made me think that maybe I'm sensitive to that, because in the second round, I don't know if it was playing games with me. I absolutely got it wrong flat out, even though they were the same values ppm. So that kind of rules out that point that maybe I'm sensitive to those values, or there are other mitigating factors that influence that. But that's kind of where I was at. So.
Okay.
I was spot on the first one, and I was same group as Phil. So group 3, I got 836. It had funk to it. It definitely, like, I was like, oh, there's your sulfur. And then I got it on the second one on 999. That one was, it just was really pungent, very green to me. But then the second sample, totally didn't get it. It just came off as chalky minerality to me. So, and I for sure, on the first one, I much preferred the lower SO2, because it just kind of really, I got a whiff. I was like, oh, this is Chardonnay. And like, it just was classic Chardonnay on the nose.
Yeah, so that was one of Kirsty's concerns, is whether or not these wines would still show Chardonnay varietal character, or whether that varietal character would have been dampened down by the higher sulfur dosing. But I think what we saw last year was, in a lot of ways, those things that would make up varietal character were actually kind of more protected by the sulfur, which is really why we use sulfur to begin with, right? Is to protect those things from oxidation. So Melanie, you say just don't do it on rosé. So why not to do it on rosé?
I just wouldn't recommend 125 parts. I mean, my rosé wouldn't be pink anymore if I did that. So I wouldn't do that. I'd have a heart attack, so never. But
So
if
what
you're making Chamberson rosé, you can do it.
Yeah, that might be the answer for Chamberson rosé. What kind of addition do you do on your rosé?
So I treat my rosés just like my stainless tank whites at 65 parts when I'm done. Okay. with primary, and I rack there, and then they get to bottle pretty quick. So I will test and add again if I need to, but sometimes that 65 is enough. And that's all
I was going to ask, are you ending up having to do that other addition or not? But I guess too, when you bottle them early, it's not like it's aging for very long. So
right.
So and then Rick says that he also, Lee says that he prefers the 100. He says because he's lazy, but I would just say that he's one of those really busy people that has a million things going on like the rest of you. And he says he prefers the nose. So in that case, that might go back to that sort of aromatic, like the trade-off between can I smell the sulfites versus are the sulfites actually protecting the aromatics. Rick agrees with that, and he thinks that next year we should try 125. Rick, we includes you. So we'll talk about that soon and see if you want to pick up doing it. These are really approachable experiments. If anybody wants to do some of these experiments in your own winery, you just need some matching barrels, and you do them after harvest. It's not a huge thing, and you can really learn some things in terms of what that's happening. So Rick, I'll come back to you and ask you about that later. And then so Sharon's asking, could the difference have something to do with something in the chemistry of the different grape lots? Certainly, Sharon, that does. So I think again we're thinking about this that the binding of SO2 at the time of, we had different binding complexities of those two different things, and we certainly have different aromatic components as well. So Kirsty, you have done this 3 years in a row. So given what you smelled and tasted and the numbers that you saw, what do you think you'll do in your Chardonnay for going forward? And, what else are you thinking in terms of SO2?
Yeah, I think I will probably not go back with a 100-part add. I think I would prefer a 75-part add, simply because I'm generally bottling these wines, or all of my wines, a little bit earlier than some of you. So I have seen slightly higher than I would like molecular going into bottle from some of the wines that I've already bottled from this year. And I think that's due to that very high initial add. So even though I have better protection and maybe just get to do that one addition, I think I'm going to have to look at pH a little bit more, rather than just doing a 75 or 100-part add. I think I really do have to go back to looking at the pH and factoring that in more than I have in the past. But I think in terms of SO2 in general, I think I've exhausted just about every experiment I can come up with for SO2. So I think I might give something else a try. I think I'm gonna work on timing of acid additions. I think that's my goal for this year.
Great.
Yeah.
Well,
yeah.
And I think, one thing for you too, Kirsty, is that you bottle under a screw cap. And so you might think differently about your SO2 regime and what's going into the bottle there versus what would happen if you were in cork as well. So, but I like that point of kind of looking at the pH of the wine and making some decisions to fine tune a little bit there, because if you're going for a molecular target, your free sulfur target is going to move based on that. And I think we saw that in that contrast between Seaview and Blenheim in this experiment as well. So we have just a couple of things that have come in here. So Kylie's asking about the poll results. Yeah, I can reshare the poll results. Let's see, share the poll results as to when. I may not have added those. So, or I may not have shared those. I might have just read them to you. So I will reshare those so that you can see them. Sorry, that's my bad. Okay, and then, okay, so I think that was it for here. Any other additional sort of questions or comments for our experimenters? And I was sort of joking with Rick, but at the same time, and this is a good time to start to think about what kinds of experiments you're interested in doing next year as well. So, if there's anything that sparked your fancy this year, anything you're like, hey, I'd like to pick up with that, or anything you're just sort of noodling around as you think about planning for harvest, please, feel free to reach out at any time. I would love to talk you through in-house experiments, whether they're through the WRE or just things that you do on your own. So keep thinking about those as well. And then before we go, I do want to make sure that we thank each of our experimenters. So thank you to Kirsty and AJ and Phil and Rachel and their vineyards and wineries that support their doing this work. And also thanks to the Virginia Wine Board, who provides the funding for the Winemakers Research Exchange. And thank you so much to each one of you for filling out your sensory forms. That really does give us really important sensory data that we'll be able to bring back to our experimenters and know and get a little bit more dialed in for those questions like aromatic intensity and Chardonnay varietal character. So thank you all so much for your attention today. I will stay around for a little bit, and if our panelists have the time, we'll ask them to stay for just a couple minutes in case anybody has additional questions you want to throw in there. So thanks so much, guys. I'm sorry we went a little over, but thanks for sticking around. So we'll see you next time. Oop.